Good evening. I'm going to talk now about, well, what for me, at least, is a fascinating project. First of all, I have to say that I am, of course, not a musician. I'm just an engineer, computer scientist, or a scientist, as it said. The thing is that, we typically in science try things. Many times we try things. And several times I tried to map structures, data, onto music. One of these times, something special happened. So, my name is Francisco Vico. I am Professor of Artificial Intelligence at the University of Malaga. And the project I'm going to talk about, Melomics, is about building, designing computer composers that can do something different from what you probably have in mind at this point, something like the Casio-like stuff. I'm going to divide the presentation into 4 blocks. Basically, I will start talking about the basis, the scientific basis of Melomics, what has been achieved so far, why exactly we are parsing these kind of targets, and finally we will see a very brief performance of one of the works of our computers. So the Melomics concept. What I'm going to talk about is not really about music. I'm going to talk about science. The way in which scientists can represent differently music from what we have already seen. And the way scientists can think on ways of delivering, performing the actual music. During these 4 years that we have been working in this project, we had the occasion of learning a lot about music. We learned that music is essential for people. It's basically sort of physiological need. It helps people in many ways. And that's probably the reason because music evolved in every culture and it's present in every day. Our mission is definitely to start a revolution in music. Pretty much in the way it was done in the past. If you think it over, with Napster, a real revolution started. It's not that provoking piracy is a good thing, but it showed us something very important, that people wanted to share their music not only with a neighbor or with some friends, but with basically everybody. So we want really to share our music. Pandora, Spotify came after that, and they show us that there are other ways to reinvent the way we consume music. Well, this revolution is not about the way we will broadcast or multicast the music. It's about the way the music will be composed and offered to the listener. The inspiration of all this project comes from biology. This is nothing new at all. We basically copy all the time the models of biology. In this case, what we are copying is not a particular model. What we are copying is a strategy, the strategy of life to evolve and to develop complex structures from scratch. So, genomics is about everything that has to do with the genomes. So, the dynamics of the genomes, how do they change in time, and how do they recombine, and how do they end up into very complex organisms. Actually, all the diversity and complexity that we see in life is definitely a sort of inspiration for us. So we can see that complex multicellular organisms have developed from very simple, initially, unicellular ones. We can see that new species have developed from older ones. In the same way, Melomics codes with artificial genomes every composition. So behind every piece of music, there is a genetic encoding of it. That's a very powerful idea, if you think about it. So with the same strategies, like evolution, we can generate sophisticated and human-level music. We can, of course, merge these genres and generate brand new genres with different parametrizations of the old ones. By genetic engineering, we can create in biology resistant families and cellular reprogramming? Well, at the musical level, what we can do is to insert jingles, for example, pieces of music into host music pieces. And we can also do a huge genetic pool of music of all times. So this sounds, I'm pretty much aware of it, a little bit bizarre and strange. Okay, I will show you how can we do all this. In principle, what we follow is a completely different strategy from what has been done before. Typically, we copy the style of a musician. This is what computers has been doing for many, many years. So this will be something like Bach music or Mozart's music. This has been done before. The thing is that we can, by modeling biology, create complexity, complex structures. If we also model music knowledge, if we introduce all the rules that the music student is learning during the times that he is in the conservatory, then we will be able to filter, to adapt, to map in a way these complex structures into musical structure. If we select those structures that make sense in a musical way, then we will end up with compositions that are acceptable by musicians. And finally, these compositions will be able to be synthesized automatically by the libraries, music libraries of computers. So this is the scheme, this is the approach that we have followed in Melomics. So yeah, it's something like that. At the very beginning, the computer, when it's trying to do a new song, has basically nothing, just a handful of notes, say 1 note or 3 notes. This is the full composition that we have commissioned, 2 or 3 notes, no more than that. It will be like saying, we want to develop intelligence in planet Earth, but we are at the bacterial time, so there is no real intelligence there. Okay, but this can develop. We can wait for some million years, and then we will see more and more complex specimens on Earth. That's how it happens. These organisms develop into more complex structures, and so on, until they reach the level of complexity that we commission. So in a way, this music is evolving inside of the computer. So what had been deliverable at this time? In 2010, Iamus, the first computer that we designed, was able to compose its opus 1, so to say, piece of music. And 1 year later, in 2011, it was commissioned by the Catalogue in Canary Island Festival, the first work that was performed, that was premiered in this festival for the very first time. So it was the first time that the computer was premiering a piece of work in its own style, not in somebody else's style. In the last years, we saw the publication of the first album of this computer, of Iamus, performed by the LSO included, and the Discover magazine included this milestone into the 100 scientific top stories of the year. And finally, another computer about 4 times more powerful than Iamus was also designed and set up. By the end of 2013, the first applications that were able to deliver music adapted to any scenario of life were also delivered. And finally, this year, we saw the first therapeutical applications of the music developed by these computers. Also, the creation of a huge repository of free music, Infinitunes. It is published until CC0, public domain for the public. And it's also composed in 2 different styles, in 2 different formats, MIDI files and MP3 files. So it can also be edited. And finally, during this symposium that Andrew was introducing, Zero Music, we launched the second album that, in this case, it is not only composed but also synthesized or performed by the computer in its own style. During the next year, of course, there will be many tasks to do, but let's concentrate on the applications that we have really developed. Empathetic players. What do I mean by empathetic? I mean the fact of being aware of what somebody else is feeling or thinking or demanding in a concrete moment. So, if you have heard about music medicine or music therapy, this is basically the scheme. A player, like the computer that you have in the screen, is providing music to a patient according to musical preferences or according to the specifications of a music therapist. And that's it. But what happens if the state of the listener changes in a way? Nothing. The music will be playing exactly in the same way. But if we close the loop by measuring automatically the biosignals and feeding the computer with this information, then something special will happen. The music will adapt to the needs of the listener. And this is what we call empathetic players. This has been, by the way, funded by the Spanish research program. Well, let me show you very briefly a demo. Oops. So this will be the music that is played. Is this connected to the, yeah. It is connected to the, yeah, okay. So this will be a music that the system is playing for a person that tries to fall asleep. Say a person with, let me put it a little bit down. With the sleep disorders, okay? So the thing is that by simply measuring the activity of the person on the bed, you can guess whether the person is getting asleep or it is still finding the right moment, okay? So the same song will adapt, will change, like if the system will be empathetic. Let's say that at some point, this person is moving a little bit on the bed. This is detected by the system, by, say, a mobile telephone, and the music goes again up. It gets attractive. It's trying to to attract the attention of the person, to the patient. Finally, after some time, without any movement, it goes down again, and so on. So it is not just a music that is not listening to the state of the listener. It's actually watching it. Okay. So this is a way of illustrating what I mean. This will be the different stages by which the listener is going through. Another example that I want to show is native advertisement, the possibility of introducing jingles of concrete brands into music. So instead of stopping abruptly the music and saying, this is the commercial, I will make you aware of something new by just putting the song inside of the host that is playing actually. Oops. So something like this. For example, this will be any song, okay? So the thing is, we reverse engineer the Nokia tune, obtain the genome of this particular song, introduce it into the genome of a bigger song, and this is what came out. At some point, this music develops and is included in the main home. Well, this is a very powerful concept. On the other hand, we can also think about different formats, different way of representing the music, not only scores, not only audible formats, MP3s. For example, like the Blender Foundation is doing, they created the concept of open movies. This is a way of distributing for free content, but not only the movie itself, but also the creative process. That's very, very useful. I mean, one thing is that you give me the possibility of watching at the movie itself. But another interesting stuff is that you give me all the stuff that was developed during the creation of the movie. This is what they do. Everything is available there for free and allows other people to create movies with that assets. Well, the same thing can be done with music. You can have audible formats, but also editable formats and label, because in the end, you have perfect information about the music. This is not music information retrieval. This is like having the composer here telling you everything he or she knows about the composition itself. So the labeling cannot be better. With all this information, people can do great things. That's because I'm trying to say here that in that way, everybody can compose. I mean, if you have enough talent, if you have good ear, if you have sensibility, and if you are given the structure of a composition, maybe you can do better with that. Maybe you can modify it, adapt to your own criteria, and produce something great, but without being in the conservatory for 10 years. But it's important. So that's what I mean. If instead of only MP3s, we distribute MIDI files and XML files, people will be able to do music. Many people will be able to do music, not only musicians. And this could take to the commoditization of music, in the sense that knowledge plus editing tools gave rise to Wikipedia. This is all the people needed. Just a very simple program that allowed everybody to edit a web page. That was the big innovation, a very small program that could be installed everywhere. And with that, we actually have Wikipedia. If you have computer works, if you have pieces that are maybe not perfect, but good enough to be considered music, and people modify them and adapt to their own requirements, then maybe in the end we will have artworks, but a lot more, of course, because the computers can produce millions and millions of pieces every year. Like Ratatouille character Antenego pointed out in Ratatouille movie, not everyone can become a great artist, but a great artist can come from everywhere. And that's true. And it also will open new markets, not only for the personal expression, not only making it more closer, more feasible, the possibility of expressing yourself with your own music, not with the music of somebody else. But also for music education and training. If you will have scores of any type, say to play piano, violin, or anything, then you could take from there the precise score that you need for this concrete student. Music-based games, music medicine, and also sound branding. Imagine, many companies have a lot of money invested in branding, but there is very, very little instead invested in how the brand sounds. So this could be also a possibility in the future. And now, I would like to present Jonathan. Jonathan, are you around? Oh yeah, you're here, thank you. So he will be in charge of interpreting one of the pieces that was included in the first album published by Iamus. That is a violin piece. This was interpreted at that time by one of the violinists of LSO, and he was kind enough as to present here this piece of work. This is, of course, contemporary music, contemporary classical music, what we are going to hear now. What's up? I don't know what is the problem. For the beatbox. This, Andrew is not the wrong.
If you talk for just a couple more moments, and then we'll...
Okay. Okay, so just to fill in with this, let me show you just a funny thing. These are versions of the Nokia tune that were generated by the computer by mutating the code, the genome of the original Nokia tune. It's just a question of curiosity. So this was the original one. What we did was to find the right numbers that were expressing into that particular song. And then by modifying those numbers is what came out. It's a really powerful idea, the fact that you can do music by benefiting from the biological strategies to create diversity and complexity. I think it illustrates very well the concept. Is Andrew around? I think I saw Andrew here a few moments ago. Oh, Andrew, you're there. So, what are we waiting for?
We have a beatboxer who would like to join you on stage. He's very keen, and he's on his way. He's in a cab. I would love to hear this performance as it's meant to be heard. Like I say, the heart of Music Tech Fest, and an incredible vocal beatboxer who is going to be responding, as I say, to the live solo violin piece created by Iamus. So I'm going to hand over to you guys. You've had your minute. These guys have never met. This is how we work.
So, thank you, Jonathan, for a wonderful interpretation. Thank you, Jason, also for contributing to enriching the genetic pool of the song itself. Thank you. So I feel really strange because it's like if somebody else would have introduced the genes of another presentation into my presentation in a way. I mean, it's the first time that it happens to me, but let's try to conclude this intervention with a summary of the take-home messages. This will be, computer composers have reached human level. It's not only that we can sample instruments and make it, put together everything into a final MP3. It's that they can actually compose not only contemporary music, but also popular genres. And this is something that probably will change many rules. Second, new computer formats and players will explore music as it could be, not only as we already know it. Computers, think about it, are not biased. They don't care about what people have done about music. They only know the rules to make the music. So they are really going to explore a lot. And finally, computer composers might accelerate the commoditization of music. If computers produce music by the millions, this is something that is going to change also many rules. So thank you for your attention. Thank you, Andrew. Thank you, Michaela, for this wonderful environment and for providing me this opportunity.